Yeah, so when you open this drawing, it's going to give you this reference thing. Just say ignore. Okay, so this is a scaled architectural drawing of the Stevens Center. And so far, we've not really been messing with scale very much because everything we've been drawing is just abstract diagrams. But this is a drawing of a real thing that exists, you know, and we want it to look like the real thing. We're not doing a diagram. We are doing a picture, okay? And that means that units mean something, and lines, the size of things matters. As far as like lines and doorways and things like that. And this is probably, usually these will be drawn by like a technical director. Occasionally the scene designer will do it in CAD, but in my experience they tend to draw it with a pencil and then they give it to a technical director who then draws it in CAD. But let me show you a couple of interesting features of this. Because the technical director is going to draw this, they are going to draw it in what are called architectural units. And 1 unit is going to equal an inch. Why? Because that's the way the measuring tapes work in the shop. Okay, when they have to measure and cut things, those measuring tapes are inches, and they're not like decimal values. Okay, they're like ½ inch, ¼ inch, or whatever. And everything is in inches. So this thing is drawn in inches. And the way I know that is that if I start to, let me just like pull up units here. And I'm going to switch it to decimal just for a moment. And I'm going to go measure something. Let's find something to measure. Okay, there's a doorway. How wide are doorways, generally speaking? I mean, close. Yeah.
Like 4 feet.
There's a doorway.
I don't know.
It's about 3 feet. So I'm going to measure this. The command is MEA for measure geometry.
Bro, I didn't know you could do that. I'm so using that.
It's telling me that this is 36 by 89. Okay. Okay, so our units are certainly not feet because that doorway is, there's no way in real life that's a 36-foot wide doorway. But if this was inches, would that make sense?
Yes.
Because how many inches are in a foot? 12.
Times,
12 times 3, 36.
Crazy.
Okay. So this drawing was drawn in inches. So 1 unit is equal to an inch in here. Now, so far in all the drawings we've done, 1 unit is just equaled 1 unit. We've not been trying to connect those units to anything real. But when you get a drawing like this, the units mean something. And in this case, they mean inches. So let me put it back now. Oops. Let me put it back to the architectural. And architectural units involve fractions. And this is because of the way the measuring tapes work. So if you look at, now if I do measure, and I hover in there, it says 3 foot 0 inches by 7 foot 5 inches. Okay. Well, guess what? That's exactly how you have to type it in. So if I want to draw a line that is 3.5 feet, okay, watch what I'm going to do. I'm going to do L, enter, I'm going to start it there, I'm going to go this way. And I'm going to say it will be 3 feet space, oh, sorry, not the space, try that again. 3 feet dash 6 inches. Now, and then if I measure that, 3 foot 6 inches. See how that works? So that's how you have to deal with architectural units. Now, later, I'm going to, because of the way that our tools work, architectural units are very frustrating for us because we have to, we have to do math on this stuff. We have to. There's some ways that you'll learn about this in the sound system design class, but because of the speed of the way sound travels and stuff, the kind of math we do is really hard to do in inches. So we would prefer for things to be in decimal feet. That makes our math a lot easier to do. So you're going to end up scaling these drawings later, but for now, we're going to leave it as is. So what we are seeing here is this is called this view is called the section view, and what they've done is they've basically cut the building in half vertically, and you're looking at it from the side as though you were that there was like a line drawn around the middle of the room. Okay, that's the section. You're looking at it from the side. This allows you to see how height works. Okay, and then we've got 2 different plan views. So this is the plan or ground plan view, and in this case, it looks like they have cut the building in half just below the balcony and taken the top off, and we're looking at everything that's below the balcony. Okay? And then here, they've taken the roof off, and we're seeing the balcony. You see that? So that's why there's 2 different ground plans, is because this has a balcony, and you want to be able to see sometimes the balcony, sometimes not the balcony.
What's the left one?
That is the plan. It's the same copy. It's a plan view of this thing, but just over here. And there's a reason for that. Because the way these get drawn, and AJ knows this because I'm guessing you know this because of hand drafting, and also stage managers deal with this a lot, is that the first 2 lines that were drawn here were probably these 2 lines. Okay, this horizontal line here and this vertical line here. This is called the intersection of the center line and the plaster line. Okay, center line is, you can guess what that means, the center of the room. Okay, what's that?
Is it really?
Yeah, the plaster line is maybe slightly less intuitive, but in theater we think of this term plaster line as the edge, and usually, in olden times, although in Stevens Center it is actually plaster, the proscenium arch was usually molded in plaster, okay? And the plaster line is essentially the difference between the stage and the house. House meaning where the audience is, stage being where the performers are. So the plaster line is the line between those things, okay? The edge of the proscenium. So in this case, the proscenium is indicated by this little shape here, and the plaster line is lined up with the upstage side of that proscenium arch. We call that the plaster line. That's just a thing in theater, and that's how we do it. So you just have to sort of accept that. But then what they do is, so they'll draw those 2 lines. They'll say, this is the plaster line, this is the center line, and everything then is drawn relative to that. So if you're going to draw this space, you're going to start by drawing those 2 lines, and that is 0, 0 for you. And then every other line is drawn relative to that. And so if you're doing hand drafting, that's what you do. You're going to draw a vertical line for your center line, and you're going to draw a horizontal line for your plaster line, and then everything goes from there. If you're in the real space, you're going to put little tape down on the floor indicating those 2 lines. And then you're going to measure everything relative to that with actual measuring tapes or laser distance things or whatever. And you get all of the information you need. Stage managers do this all the time too, when they'll get the drawing from the set designer, and it will also be drawn relative to centerline or plaster line, and they will go into the rehearsal room, and they will lay out measuring tapes that represent the center line or the plaster line, and then they will measure with a scale rule on the actual, because the thing that's plotted on the piece of paper is plotted so that, yes, there's a scale rule. Thank you.
Yep.
This is a perfect visual. This is a special ruler because it has a few different things. This is real inches. Okay. This one is the half-inch scale thing. What this means is it says 1/2, and that means for every 1/2 of an inch on this ruler, that represents 1 foot in real life. Okay? And this is the 1/4 inch scale, so for every 1/4 inch on this represents a foot in real life, and it's labeled that way, so it actually goes, 1, 2, 3, 4, 5, 6, 7, 8, but every one of those represents a 1/4 inch, and that's 1 foot in real life. And so when the set designer or the set director actually plot this onto a piece of paper, they do that in a very deliberate way so that, because this drawing is drawn to scale in inches, and it represents something that really exists and measures like something in real life. And they make sure that, although AutoCAD is not scaled, right? AutoCAD is drawn in full size. So they plot it out so that an inch or a foot or whatever in this drawing shows up as a very specific size of line on the piece of paper that you can measure with a ruler like this. Okay, and that's a very, very specific process that they definitely try to make sure they get right, so that when you put that kind of ruler on that piece of paper, you can see exactly how big the line is in real life. So you put that thing up there, and you measure it as a 3/4 inch line, and if it's in 1/4 inch scale, you know that is a 3 foot line in real life. And so you're going to get a 3 foot piece of tape and put that down on the floor to represent that line.
We play like connect the dots.
Yeah.
We have the tapes out and we'll go like 4 feet up and 4 feet to the left or whatever, and then
Yeah.
the dots out, and then we connect them at the end.
Yep.
But I use this all throughout rehearsal just to measure the ground plan. People have questions on how.
Oh, yeah.
how big. Keep it in the room.
Yeah. So if they're going to draw this line, for example, they're going to go and they're going to find out, okay, well, that is that far on the X, that far on the Y. They'll put a dot on the floor. They'll get this line. They'll say, okay, that dot is that far on the X and that far on the Y. They'll put that dot, and then they'll take a piece of tape and put it down there. Okay? So that's how this works. Now, what we're going to do is let me just show you how to measure, how to do that, how to measure stuff. You have to be able to move the UCS in order to do this. So if I want to look at this orchestra level plan view, I need to move my UCS to that spot, because I don't know where it is right now, but it's certainly not there. Let's find out. Where is 0, 0? Oh, it's right here. Okay, so I'm going to move it. So I'm going to type UCS, and I'm going to put it right there at the intersection of the center line and the plaster line. Okay, and then it says, okay, which direction should X be pointing? Yeah, I want it to point out here towards the audience. Usually that's what we're going to do. Let me shut this door. Noisy people. All right, and then it says specify a point on the XY plane. This is basically which direction should Y be going. Usually this would be this direction, off stage left. Okay, and now you see that XY is pointed there. And now when let's say I did want to go draw that line, I could select it and I hover over it. Okay, that line as 15 feet 8 5/8 inches on the X and 22 feet 6 9/16 inches on the Y.
How did you click it and just get those measurements on that?
So I selected the line and then I hovered over the end point. And then if you look down in the bottom right of the CAD screen, it tells you where that lives. Okay. So there you go. Now you know where every point is. Well, what if I need to know? What if I need to know where? Let's say I'm going to hang a loudspeaker right here. That's where I want to put a loudspeaker, okay? I'm going to hang it right under this shell, and I'm going to hang it there and up in the air, because we have to deal with things up in the air, okay? In the ground plan, you don't get to really think about what's up in the air. You're just looking at the ground, okay? And I want to know how high up in the air that is. Like, where is that vertically? Well, right now, over here in the ground plan, we have X and Y, right? And that's indicating this two-dimensional scale. X is pointing out to the audience, Y is pointing off stage. Well, the third dimension is Z. And Z goes up into the air. And Z is implied here. We just can't see it because this is a two-dimensional drawing. Okay? But sometimes you'll get an actual three-dimensional drawing where Z will exist. Z does not technically exist in this drawing because there's just no axis to measure it. But Z is represented over here in this section view. And so if I want to find out Z, I have to move the UCS again. And in this case, instead of putting it on the intersection of centerline and plasterline, I can't do that because centerline is not really visible in this section drawing, okay? So I'm going to put it at the intersection of the plaster line and the stage floor, the stage deck. That's usually what we reference. So here is plaster lines right there, and the intersection of that and the deck. Now, how do I know for sure that's the plaster line? Well, I can kind of see here where the upstage of this architecture lay. That's probably it. But if I wasn't totally sure, I could do a construction line called an X line, and I could click here and make a vertical line that would go on forever. You see that?
We did X lines last week.
Yeah. And I can see that theoretically that's where that should be. It should correspond with that line, but it's off a little bit, isn't it? So let's fix it. I'm going to take this whole section view. I'm going to select it, and then I'm going to move it. Enter. I'm going to zoom in, and I'm going to grab that spot where the actual plaster line is. See what I'm doing? Click, and then I'm going to put it there, because that's where the real plaster line should be. Because I want them to line up. I want the.
Where did you go to put the X line now? Okay. Oh.
So I went into the ground plan.
Yeah.
I made the X line at that intersection of center line and plaster line. Then I had it point the direction of the plaster line.
When you selected what all did you hold?
I just selected the whole section view.
Okay. So in theory, there's probably a little like on the edge you trimmed. When you shifted it over, is there like a little line that you need to trim off from that edge then?
Well, that edge is just a reference line. It looks like that's not architectural. It's what it's meant to show is that the back of this lines up with the back of this balcony. But we'll deal with that in a sec. So so I'm going to select this. I'm going to hit Move, Enter, and I'm going to take this and go there. And now the plaster line is lined up on the section and ground plan. Okay. Now what I want to do is let's make sure it's lined up down here as well. And it is. Okay. And then yeah, now we can see that this line is a little off, but again, that's not architectural, but let's go ahead and get rid of it for now. And what should be happening is the back of this projection booth should theoretically line up with the back of this. And it almost does. So one of those is wrong a little bit, has been drawn incorrectly. That's not super important for right now. We don't need to worry about that. But ideally, those would line up. We don't need to fix that right now. And then the other thing we want to do is this one here is meant to have the plaster line up with the stage deck. It's just a flipped version of that ground plan view. So I just want to make sure that that's happening too. So I'll do an X line off the stage deck. And let's just go over here and make sure that that's lining up. And it is. Okay, so all of these drawings are lined up relative to the center lines and plaster lines. This is going to make things a lot simpler to deal with. We can get rid of those construction lines now if you want to. So now what we want to do is, the reason that we would use this drawing is, and what you're going to do today, is to figure out where you're going to put all your loudspeakers for your sound system. We call this a loudspeaker plot. And the important bits of information here are where does it go and where does it point? Those are the two information. How it gets there is less important for this drawing. And what I mean by that is like the rigging part of it and how it hangs there and all the hardware and all of that, that's less important for this drawing. Later that becomes important. And eventually you got to get to that point where you figure out how to get it there, and that requires talking to other people, and they're going to want to see how big the thing is relative to real life, and it matters then. But for our purposes, for communicating to each other where things go, scale is not super important to us, because some of our stuff is really small. I mean, we have speakers that are sometimes like this big. And if you draw that in scale on this huge building, you're never going to see it. And you're never going to be able to figure out where exactly it goes because it's just too tiny. So it's okay for it to be a little bit bigger. Now, not everyone in the world is on the same page with me about that. I think that scale shouldn't matter as much in this version of a loudspeaker plot, where you're just trying to figure out where does it go, where does it point. When you start getting into rigging and building it into a scenery piece and everything, then you got to worry about scale. My argument is that's a separate drawing. That's a close-up view of that spot, and you're going to do that in scale, and you're going to see how it fits and everything. I don't think that needs to be the loudspeaker plot. But you will find people who disagree with me on that. That's fine. They can disagree with me, but I'm still going to tell you how to do it the way I think it should be done. So let me show you then what we want this to look like. So this is the example of a loudspeaker plot for a sound system in Stevens Center. And this is from a real show I did there with Piedmont Opera several years ago. And what I'm doing is this is a center cluster that is up here behind this thing that we call the eyebrow. And I've got 3 loudspeakers in there. And they are here, and they are pointed to these places. And then I have some front fills down here on the edge of the stage that are pointed up towards the balcony. I have these ones hanging under the balcony that get pointed to the back row. I have these ones up in the balcony that are pointed at the back row. And then you go to the plan view, and you can see how they lay out that way. So you'll see here in the plan view that all those ones in that center cluster are centered on the center line. But those 2 front fills that look like one thing in the section view are actually 2 things. And they are spread out this way. And even though I have in the section, I have them pointed at the back row of the balcony, they are also tweaked horizontally slightly to the left and right. And I can only see that in the ground plan view. You see how that works? You kind of need both views in order to communicate all of the information. Well, how do you decide where things go and where they point? Well, we'll learn about that when you take the sound system design class for me. But basically, you are going to use an acoustic modeling tool, okay, that is going to have a three-dimensional drawing of the space. And it's going to leverage the information about the directivity of the loudspeakers, and you're going to figure out where things need to be and where they need to point. And it is going to generate this kind of information. Okay, so these tools are called like ArrayCalc or Ease or Sound Vision or Map. These are all different modeling tools you can use to figure out where loudspeakers need to go. But they're going to generate this kind of information. The loudspeaker is here. This is where it exists, X, Y, Z. It points here, meaning if there was a line coming out of it in real life that went on forever, eventually it would hit something in the building, and this is that spot. Okay? This is what comes out of those modeling programs, is this kind of information. You have to use this information to then draw it out. It's very similar to that process we just described that the stage managers do. The difference is you're not using rulers, you're just like, you have the list of the coordinates already, and you're going to put things in that spot. So the first thing you're going to notice is that this is in decimal values. See that? And I just spent a whole lot of time talking to you about how this drawing is not that. This drawing is in inches and uses fractions and all of that kind of stuff. So what do you do? Because the drawing comes to you from the TD like this, but the information comes from the modeling program like this. So you have to change one of those things. Which one are you going to change?
Decimals and inches.
So if doing that would require you to do math on every single one of these numbers as you get through them. That is a way of doing it, yes.
But couldn't you just change it to decimals in AutoCAD?
Yeah, I could just change the drawing.
Oh, do that.
And then I can do that once, and then I don't have to do math on these numbers.
Yeah, that's easier.
Yeah, either way is fine. You can do it either way. But I would suggest that scaling the drawing is easier.
Easy to change it back.
Yeah.
So obviously, like, if we're drawing these not in scale, that's fine. But if we needed to give that information, like rigging,
Yep.
whatever, you just change it back.
Yep, you can change it back. So let's do this. So the first thing I'm going to do is let's type units, and we're going to change this to decimal values. Okay. So, right? So just under length, under type, just put decimal instead of architectural. And now it's decimal inches. Okay? How do I know that? Well, let's just double check. If I do my measure tool again, this is doing 36.00, and that's inches. Okay? So it's no more fractions. It's just inches. And if I check this, now I'm getting 188.5949 by 270.5336 XY. That's inches, decimal inches. Well, this information is in decimal feet.
So do we need to change it to?
So we need to scale this drawing so that so that 1 unit equals a foot instead of 1 unit equals an inch. So how are we going to do that? We're going to use the scale command. Type scale, enter. It says select objects. You're going to type all, A-L-L, enter. It will select every object in this drawing.
Oh.
Okay? And it still is going to give you the option to select more things if you want to select more than all. So once you are confident that everything is selected that needs to be selected, you hit enter again. And it's to specify the base point. The base point is, this thing is going to ultimately shrink. And it should shrink down on a certain spot. It doesn't really matter.
Would it be where the plaster line and center line?
That would make some sense. But ultimately, it doesn't matter. All you need to put is 0, 0. Enter. Okay, so yeah, now if you start moving your mouse around, you can see the whole building is like growing or shrinking, okay? But what it's asking you is specify a scale factor. And we need to be very precise about this. We don't want to do this by just clicking the mouse. We're like, it looks about right. No, you got to get it exactly right. So what are we doing here? What would be our scale factor that would be exactly right?
An inch to a foot.
Yeah.
So
So we need to, an inch is smaller than a foot, right? And there are 12 inches in a foot. So I need to take what is currently 12 units in AutoCAD, and I need to squish them into 1 unit.
So
12, whatever one
There it
twelfth
is.
in decimals.
Well, I don't have to do it in decimal because it's asking for a scale factor. So I just say 1 divided by 12, 1/12. Enter. And it gets very tiny all of a sudden. And so then you can do Z, enter, E, enter for zoom extents. And now you're back in business. And now let's see where we are. If I select that same spot, now I am 15.7162 on the X and 22.5445 on the Y. Yes.
The grid lines though.
The what?
The grid lines.
The construction lines that I made?
No, like, isn't there like lines on AutoCAD
oh yeah, they're up there.
that like are in the background?
Oh, I have those turned off.
Oh, okay.
I mean, you can turn them on.
Do you recommend them?
That's up to you. They're just turned off in this drawing, but you can. There's this little button here, grid display.
I see.
Yeah.
Now it is showing us this information in
Decimal feet.
decimal feet.
Let's confirm. Let's confirm that we've done this right. Here's our friendly doorway again. I'm going to measure the geometry, and it says 3 foot by 7.4716 feet. 3 foot by 7.9. Yeah, that sounds right. The 3 foot is the right thing, right? So that seems right. I think I've done it. Always get yourself a little something like that you can reference. And reference it before you scale it, and then reference it again after you scale it, and make sure that the number makes sense. Okay? It needs to be a nice whole round number like that is not going to be ambiguous when you scale it. You'd be like, oh yeah, that says 3 now. It used to say 36. I've done it right. Okay? So now we're sitting in decimal feet, and now we can do this. All right? So let's pick one of these things. So this first one is called the Center Cluster Top Q7. It is located at X 14.6446 and Z 39.6097 and Y 0. All right. Well, let's do the section view first. So I'm going to come up here to the section view, and I'm going to move my UCS. I'll say UCS. I'm going to plop it right here at the plaster line and stage level. And I'm going to point X out towards the audience, like it always is. But in this case, I'm going to use Y in place of Z. So I'm going to have Y pointing up. Okay, so Y is going to pretend to be Z for now. And what I'm going to do is, before I draw this point, I'm going to go over here to Format and pull up my point styles. And pick whatever style you want. I like this one, the little 0 with the X. And put set size in absolute units. And I had it set to 12 units because I wanted it to be a 1 foot size dot before, but now my units are different. So now it's drawing it as a 12 foot size dot, and I don't want that. So I'm going to do 1 unit.
How did you get the Y to be the Z?
So you're going to type UCS.
Yeah.
You click here
Yeah.
at the intersection of the plaster line of the stage. You point X that way, and then Y you just point up.
Oh,
Okay.
Isn't that what we usually do to make regular Y?
Yeah, but right now I'm doing it on the section view.
Oh, yes.
And if I was drawing the section view as 2D, then yes, I would use Y as the vertical. right?
Understood.
But because of the modeling tool I use to come up with these loudspeaker positions, I'm getting X, Y, and Z. Okay, so it just means when you're on section view, that Z value is going to be represented by Y. Okay? So it's just you just have to, don't forget that, okay? So here's what I'm going to do. Now that I've got that set up, I'm going to first get myself a new layer here. And I'm going to call this because I'm doing center cluster, so I'm going to say sound center cluster. And I'm going to go ahead and make that a different color.
How do you add a layer?
So over here in the layer view, you can click on this little button in the lower right. It says new layer.
Yes.
Yeah.
And then you said center question.
That's what I'm calling it. You can call it something else if you want.
You just choose whatever color you want. How do you be thoughtful about what colors look good?
Well, you think about, you got to think about something that's going to be visible both against a black background and a white background. Because ultimately we're going to use color to our advantage here when we plot this. And if you just use like the atomic pink or magenta here, that's going to look really great against a black background, but you plot that against white and it looks really weird. So you kind of end up having to add a little bit of value to some of these colors to make them work on both sides. Okay, so that's just a trial and error, think about it thing. All right, so I'm going to draw where this loudspeaker needs to go, and I'm going to do it using a command called point. Point, enter. Oh, hang on, but let me select the layer first. There. Specify a point, it asks, and it wants an XY value. Well, what is the XY value? Location is 14.6446 for the X. So I'll start typing that. 14.6446, comma, and I'm going to use Z here, 39.6097. And then I'll hit enter. And look, there's a point hovering right there. That's where this thing's going to go. Okay? And now let's get the aim point. So where is this thing going to aim? It's going to be X 97.4036 and Z 50.1855. So I'm going to do another point. And the X 974036, comma, 50.1855. Enter. Oh, where did it go? Well, it's actually all the way up here. Back row of the balcony.
Can you go back to the point? I like it scrolled out and it made my point disappear, so I lost my image.
Also, Jason, when you want to, oh, no, I might have to do this. My thing wasn't on the right layer, so I'm trying to switch it back, but it looks like the layer is locked or something.
It's probably frozen. What layer did you draw it on?
0.
Oh.
On accident, I.
Yeah.
meant to
So
switch it.
so escape. Okay. Go over here. Select the active layer that you want to be drawing on. Okay. And then go and find the thing you want to move to. So let's say I want to move this ellipse. So I'm going to click that.
It didn't do that for me though. Like, it's not letting me switch to my center layer. Because it's like, there's a lock on it. Oh wait, okay. I took the lock off. I don't know.
Okay.
It's still not working.
Okay. Escape. Get out of all of your commands. Okay. Now, just go over here to the layer list.
Yes.
Select the layer you want to be drawing on, which in my case is Sound Center Cluster. Did that work?
No.
No, select it here from the menu.
I had accidentally turned off.
Okay. Oh, you've frozen it.
Oh,
Unfreeze it. There you go.
okay.
Now
How did I do that?
select it. There you go. Now you can select that, and now go here and select the later one. There you go. Okay. Everybody else with me? You got these 2 points?
Yes.
Wait, when did she do your other point? What other point did she do?
I did the aim point for this thing, right?
So you just type in point and then X.
Same thing. All right. So now what I need to do is I need to draw a little box that represents that loudspeaker. I'm going to just use the rectangle command, and I'm going to draw a rectangle that is of some approximate size. Okay. This does not super matter.
Shouldn't it matter? Do we have to use the command line, or can we draw it?
You can. I mean, I'm going to just draw it.
No!
Now-
Does it matter? Should you know, at this point, do you know what speaker type you're using?
It is a. This one is a D. It says a D&B Q7.
So can't you look up the measurements for
You
it?
can.
But you don't like that?
Well, for something like a Q7, that is like 2 feet by 1 foot. So, like, okay, sure. But something like the E0 is like 4 inches by 6 inches.
Okay.
And if you draw that in real size, it's going to be this teeny, teeny, tiny thing,
Right.
and it won't be easy.
Yeah.
So it won't be easy to see it.
Okay.
Um,
So it's just about like vibe.
Well, remember, what is the point of this drawing?
You don't need to.
Wait, I wrote it down.
What is it?
Where it goes and where it points.
Where does it go? Where does it point?
But
How it gets there is,
But shouldn't you know? Shouldn't you have to know? Because then it depends on, well, if this speaker is this big, then I can't put this right next to it. And
yes,
then
that,
it's about
I'm
where
not
it
saying
goes.
that doesn't matter. I'm saying it matters for a different drawing.
Okay. Right. Sorry. I'm just, well, like it
Jason has played this game before.
I'm like, well, the size of it matters because then it depends where other speakers go.
Yes.
And then it's like,
It matters, but it doesn't matter as much for this drawing.
okay,
Later it will matter, because later you have to figure out how to get it there.
right.
Okay? And when you figure out how to get it there, then yeah, it's going to matter how big it is. And that is what I'm saying is that's a different drawing.
Okay.
That's a rigging drawing.
Okay.
And you're going to go in and you're going to get an actual, you're not going to draw the real thing. You're going to go to the website for the manufacturer of that loudspeaker. And they will have a CAD drawing of this thing. And you're going to download that and you're going to plop it in there and it's going to be in scale. I'm saying that all that level of detail is not important for this drawing, because this drawing is where does it go and where does it point.
Do you think it's faster to make two than to make one detailed document?
Well, sometimes the getting it there doesn't involve a committee.
Yeah, they don't need all that.
Right? But when it does involve a committee, then yeah, you're going to want to do a different drawing that has more detail in it. What we want to be able to do is, I want to be able to look at this drawing and be like, and be able to look at it very clearly at a zoom out level like this, without having to like go into these. I'm going to want to look and say, where is everything going? And where is everything pointing? Because when it comes time to do it, yes, we'll have a different drawing that's like, okay, well, how big is the chain and the pipe and where is that and how does it clamp and how does it, all that kind of jazz. You're gonna do all that, but eventually you have to figure out how to aim this thing. And you want to know I'm standing up in the catwalk and I have to aim this thing. I do not want to have to get out a ruler while I'm dangling half my body off of a catwalk to try to aim this thing. I don't want to have to go and pinch and zoom on a drawing or get out a ruler or anything. I just want to be able to look at it and go, where does this thing point? Oh, one row back from the back row. Got it.
In like, is it array count in like views and stuff? Does it, in that case, would you account for size?
Yes.
Then you can guarantee, I think this will clear up kind of what you're thinking, because if you can guarantee that that's the center, then you won't run into a problem of like, this is gonna hit this one, because the center point will stay solid. And
Okay.
then you'll just base how big the thing is around that.
Okay, we're,
Yeah. You're like 100.
I see you, I see.
You're like 100 steps ahead of me right now.
sorry.
Right?
It's hard not to ask that question.
Yes. So you're having to sort of, for now, you're sort of having to just take at face value that this data got generated somehow and it had a process that had integrity, you know.
Yeah. Okay.
And so there was a process that generated this data, and this is real data. These are real numbers, and they make sense, and they will work in real life.
Okay.
Okay? At this phase, we are not designing the sound system.
Okay.
We are just making the drawing of the thing that has been designed. Okay?
Cool. Sorry.
All right. So here we are. So what I'm going to do is, yes, I'm going to make a little box, and, you know, I happen to know that this particular box is 2 feet by 1 foot-ish, so I can go ahead and just kind of make a rectangle that's about that size. But if it needs to be a little bit bigger in order for it to be visible easily on the drawing, that is fine for this particular drawing. And you're just going to draw this somewhere adjacent to where the point is, okay? And then you're going to move it. Is everybody ready to watch to see how you move it?
Yes.
So I'm going to do M, enter for move, select that thing, enter, and then I'm going to take the midpoint on the front of that box, and I'm going to snap that to that point. Now maybe yours isn't snapping because you don't have snap to node turned on.
I'm sorry, I'm struggling to see 'cause it's a little dark. We're snapping to like the center of the point.
Yes, let me change. I can change the color and make it look a little bit clearer for you. Okay.
Thank you.
So make sure on your, but get out of that command if you need to. Make sure you right click on your object snaps, make sure node is turned on. Okay? You with me? All right. So now we can move, we'll select this. I'm going to snap to the midpoint here, and then I'm going to put it right there. Okay? Now what I need to do is I need to point this box towards the spot where it needs to be aimed. And here's how I'm going to do that. I'm going to select it and use the rotate command, R-O, enter.
Did you select the little thingy too?
Yeah, you can, it doesn't matter. The base point is actually pretty important here. So you want to click on that spot where the little node is. And then it says specify the rotation angle. Well, I want to do R for reference. So R, enter. And then I'm going to click from the back midpoint to the front midpoint. And now when I move, it's going to rotate it like that. And then what I'm going to do is I'm going to zoom out. I'm going to go find the aim point. See what I'm doing? Finding the aim point, and I'm going to click on that aim point. Click. And now that thing is pointed there.
That's crazy.
Okay? And here's now what I'm going to do. I'm going to now do a line. I'm going to draw a line now from the loudspeaker to the aim point, just so I'm super clear. And there it is. And what you want to make sure is that that line should be perfectly perpendicular. And I could verify that by doing a construction line between those two midpoints. And that construction line should intersect with the aim point if I've done this right. If you don't do that, I'm going to call you out for bendy sound. Bendy sound.
So you do it on Monday.
I did it on Monday,
You're
yes.
saying that where should the construction line go?
So if you draw a construction line between the back midpoint and the front midpoint of that loudspeaker, that construction line should intersect with the aim point if you've done this right. Okay? It's just a little way to check your work.
Oh. Yeah. Oh.
See?
Yes, yeah.
Yes.
Just to clarify, you're not caring about like how the size of our speakers.
I don't care.
I mean, as long as like I'm using that.
You need to be able to see it.
Okay.
So it needs to be not so big that it overlaps with other ones,
Yeah,
right? But it needs to be not so small that you can't see it when you zoom out.
gotcha. Cool.
Okay?
Yeah.
So at this point, if I want to, I can go ahead and erase this little point there, because now it's implied there by the intersection of that aim point.
Should we?
I do. I usually do.
No, that was like a.
And then I want to hatch and fill in this thing. So I'm going to say, all right, solids, and the color I'm going to say, do it by the layer, and click select boundary and click the rectangle, and it'll fill that in. Okay, there you go. So now I need to draw this.
Wait, how did you did it by the layer and then you said.
I'll do it again, watch. So I'm going to type hatch.
Yeah.
And you just want to make sure that you select solids
Okay.
from this thing. And for the color, you want to select by layer, so it'll be the color of the layer. And then you click select boundary, and then just click the rectangle, and it'll
Okay.
fill it in. Okay? All right, so now I need to do this in the plan view as well. So which of these two plan views, now that we know more or less, we know this information, which of these two plan views would allow me to see where the loudspeaker goes and where the loudspeaker points?
The second one with the balcony.
Yeah, the one that has the balcony in it, right?
There you go.
Yeah, makes sense.
Yeah. So what I want to do is just, again, to be able to check my work, I'm going to draw two construction lines. One will be at the aim point and point vertical like this. And the other will be at the insertion point of the loudspeaker. Okay? Now this is where all that work lining up these drawings pays off. Okay? Because I happen to know, because I looked here, that the Y location of this loudspeaker is 0. And 0 is the center line, isn't it?
For
Yes,
the
Brooke.
second excellent, it's from the like midpoint flat front.
Yep. Where the loudspeaker, the insertion point for the loudspeaker. It's that point that you typed in. So I can go down here and I can say, well, I know that the loudspeaker lives on center line, don't I? Because it says Y0. So all I got to do now is draw a point at that intersection of that construction line and the center line. And that is where it goes. And right?
Where did you draw that? Oh, never mind. You're drawing a point.
Now, let's just check my work here, shall we? I'm going to move the UCS now down here to this drawing, intersection of center line or plaster line, point X out towards the audience and Y off stage left. And then here, I should be able to select that little point, and it should give me the right location. 14.6418, 14.6446, and 0. So something's a little bit off here. It looks like my center line.
How did you see the?
I've got another center line or something
Wait, I
here.
had 16.
How did
You're looking at the number in the bottom, right?
Yeah.
Okay, but hear me out. So you're saying that this doesn't have to be exactly precise because it just has to look like what they can see. So
Yeah.
if it's off by a 0.1,
It's
why
fine.
are we fixing it?
It's fine.
That's one of the good old Jason Rocky tricks right there.
It's fine. Okay, so something's a little out of alignment here between these two drawings, but it's not a statistically relevant out of alignment. Okay. Okay. So I know that this thing will be aimed somewhere along this red line, don't I? But let's find out exactly where. Oh, look, y0. Which means I can now do the same thing. I can put a point right here at the intersection of that red line and the center line. That's where it aims. You with me so far?
So then a line again from the two points.
Yep, so go ahead and you can do that now if you want. Draw a line between those two things.
You put it on the intersection of the horizontal white line and then the red X line.
Yep, center line, yep. And then I can go ahead and draw my little rectangle for the loudspeaker. This will be 1 foot by 1 foot-ish, but big enough to be seen. Okay. And then I will take that and I will move it based on that midpoint to the insertion point, and then I will hatch it. Select boundary. Boom.
So it doesn't need to be angled because it's just perfectly horizontal.
Yeah, it's already there, right? Okay.
Can you hold on?
Yes.
See if I can do it.
Yep.
I'm with you.
Catch up, by all means.
And you don't care if the boxes that go on the speakers are not consistent with each other necessarily?
No, because it's a different view.
Okay.
Yeah.
Everybody all right?
And we just leave the angle point as a point.
Yeah.
I think I did it on the wrong one. Did you do the
So I went down to the balcony ground plan,
I see. Okay.
because that's where I can get the aim point.
If you were to maybe theoretically have a wavy sound line, what happens?
You didn't rotate the box correctly. Okay. I need to show you one of the front fills now before we finish, because that's a little bit different. Okay? You ready for that?
Yes.
Okay, so I'm going to make a new layer now, and I'll call this sound front fills. And I'll do that as a different color.
Oh, sorry, I had done mine on the wrong drawing. For the aim point for the center cluster, is it supposed to be in between the two lines?
It's on the center line, which is that white line
Yeah.
you're on, and the red X line.
I see.
So you just move it over to the right a little bit.
Yep.
Thank you.
Wait, did we even aim that one?
Yeah, you don't really need to, because it's going to be default pointed the right direction.
Yeah, I don't know why mine's slightly off. That's a problem.
Okay. We're almost out of time, so I want to make sure that I can show you how to do these front fills, because you will get stuck on this if you don't let me show you right now. Okay? So I'm going to move my UCS back up to the section view. And reposition that as we've done before. And now with my front fills layer selected, I need to enter the new points. So I'm going to get my front fill left, okay? So the location of this is 9.5 on the X and negative, actually let me do the right one. We can do the negatives. We can handle negative numbers, right?
I can do it.
You guys, I haven't fried your brain enough today that you can't handle negative
No, we
numbers
got
today?
this.
Okay, we'll do negative numbers.
Just do it now, so.
Yeah. Okay, so
Fire break, you can just watch it on YouTube later.
all right, so we're gonna do a point again, and the point is going to be at 9.5 on the x, comma, negative 0.0887 on the z, which in this case will be y. So 0.0887 minus 0.0887. See it?
Yes.
There it is.
Is it supposed to be a little bit lower than, okay.
Yes.
Jason, you buried this speaker in the stage.
I didn't, because this is the orchestra pit.
So it is. So it is.
Down, kind of, not really.
So the pit lift's going to go down, because there'll be an orchestra in there. And I want to hang the loudspeaker on the front lip of the stage, not on the, right, in this case. Okay, so now I need the aim point. Well, where's the aim point? Well, it says 97.4036 on the x, which, oh, hey, that's the same thing as the last one we did. And 50.1855 on the z, which, oh, hey, the same as the last one. So these things here get pointed to the same place as that center cluster. Okay? So all I'm going to do now, I don't have to draw an aim point because I already have it. It's that one. It's the same one. So let me just do my little rectangle now. This one can be a little bit smaller, but still big enough to be seen. Okay, so it'll be something like that. And then I will move it to that point. And then I will rotate it. So I'm going to do RO enter. I will select the box. The base point will be the insertion point, that front middle. And then I'm going to do R enter for reference and do the rear midpoint of the box followed by the front midpoint of the box. And now it'll spin on that axis. And then I will zoom up to my aim point and click on it. And now the box will be pointed up in that direction. And then I can draw a little line from those point to point. Okay. And then if you want to do the hatch right now, you can do the hatch. Select boundary. There we go. Okay? Now here's where it gets a little dicey. I'm going to do another construction line off the front of this thing and take it vertical. And I'm going to go back down here. And here is where the loudspeaker supposedly is going to be. But let's take a look at something. The actual position here is X 9.5. So let's move our UCS. Oops.
We're going to the section with the balcony.
Mm-hmm. Yep. All right. So I'm going to draw this point again. This is where it kind of falls apart just a little bit. And the location is going to be X 9.5 and Y negative 121905.
Why are you using the Y instead of the V?
Because now we're in plan view. And so there is no Z.
Oh, right.
Right? So I'm going to drop this point, and I'm not going to use that construction line yet. So I'm just going to put in the coordinates, which is 9.5 comma negative 12.1905.
Wait, Jason.
Yes?
Was this the right or the left one?
I'm doing the left one.
The left one,
Yeah, well, I went back because,
They're the same so far.
yeah, it's,
Oh, Jason put 9105 instead of 1905.
okay, thank you. All right, and now I'm going to plop that in there. So that's where it sits. Now here's the problem. That is not where the edge of the stage is.
Also, mine didn't intersect with the X thing. Like mine is in front of it.
So you probably didn't shift your center line, your section view then when we were working on that earlier. So remember it was off by a little bit?
Yeah.
So let me look at that in a minute, okay? Because I need to make this point before we run out of time. This is where we get into that realm of scale and size and all that kind of stuff. Well, in order to see very clearly where this needs to go here, I need it to be clear on the section view that it's on the edge of the stage, right? But because the edge of the stage is curved in real life, if I drew it on the section view, it would actually be somewhere back here in the middle of the concrete. And that would not be super clear. Okay, so what I want to do is I just want to, down here, I'm going to give myself another construction line. And I'm just going to take this point, and for now, I'm just going to copy it and stick it about here. Okay, and this can be approximate because you just want to make clear down here that, hey, it is still on the edge of the stage. Okay, and then I can get rid of this original one.
But it's not supposed to be on the edge of the stage, just a little bit closer.
Yeah, it's the same thing as, because see here, it's out a little ways,
Right.
right? So I want it to be out a little ways here as well. Okay. Now let's draw the aim point for this. So the aim point is going to be 97.4036 by 38.7636. So I'll do, yes. So we'll do 97.4036, comma, negative 387636. Negative 38.7636. Ah, look at it all the way over there. Okay. So it's still on that same construction line that's going vertical, but it's over to the right. You know, it's over to stage right a little bit, or house left. So I'm going to, now I can draw the line. This will help us see the aim point, because if I just had the section view, I would think this was aiming the same exact place as the center cluster, because in the section view it is aiming the same place as the center cluster. But in reality, I'm going to rotate this thing out and aim it over here to the corner on the horizontal world. And the only way to see that is to show that in this plan view. And then I can go ahead and draw my little rectangle, whatever size I decide I want it to be. I will move it to that point, and now I will rotate it so that it is pointed at that new aim point. The base point will be the front. I will reference from back to front, and I will go and I will click on that spot. And then I will hatch. Okay, there you go. You now know everything you need to know to do this.
Is there, so like, how are we supposed to know that it's actually supposed to be on the edge of the stage? Like small stuff like that?
Because I'm giving you a reference.
That's right, okay, sorry.
But the reason I brought that specific example up is to further make my case for not getting too tied up in how big things are. And you know, the point here is you're going to ultimately see two drawings. You're going to see a section view and a plan view, and you may not have a scale rule with you. You may not have the CAD file. You need to look at that and understand where that front fill needs to go. And in order to understand where that front field is going to go, you're going to draw it in technically two different places. In order for it to be clear, because you want to be able to look at the section view and be like, oh, it's right off the edge of the stage. But then you want to be able to look at the plan view and go, oh, but it's over here, right? So you're cheating a little bit. So in order to be clear, you have to be inaccurate.
Okay. Devastating loss for those of us who like
Right,
accuracy.
okay? And then later, when it comes time to figure out how that rigging actually happens, then yes, you will do a close-up view, full scale, everything annotated, all the details, every bolt, every washer, the whole thing. But for this, you don't need to worry about that. So the only thing you're going to need to add is the labels. So you want to go in and label each loudspeaker exactly the way that it is labeled in the coordinate list. And you know how to do that text now, so you can add that in. So your mission is to add all of these loudspeakers in their locations and aim points into this CAD file and label it appropriately, and ultimately you will turn in a DWG file that reflects something that looks a little bit like this. Okay?
Oh, I have a question. Oh, when should we be using different layer colors? Just for the fills?
So I did it based on the loudspeaker type in this case. So these Q series are all red, E3s are green, and the E0s in the balcony are some sort of lavender. That was what I did, but you know, you could split it up as center cluster, front fills, under balconies, balcony fills,
Okay.
and have those be different colors. I'm open to your interpretation on that.
Okay.
Okay. But you don't want everything to be the same color,
Right.
because that's boring and confusing. Okay.
This doesn't seem to be template-ifiable, right? Like,
No.
there's nothing we really need.
No. And don't worry about, this is my title block. You do not need to recreate this. I'm not asking you to recreate this drawing. Okay? I am asking you to put this information into that CAD file.
And it'll look something.
And it will look something like this drawing, but it does not have to look exactly like this drawing. Okay? But the information needs to be accurate.
Understood.
Okay? And the point is, I should be able to look at your CAD file, and without having to measure anything, I should be able to look at it and go, I know where the loudspeakers go, and I know where they point. And there is no ambiguity. Okay? That is what I should be able to do. Other questions? Anybody have any other CAD problems that you got stuck on? You had one that you needed me to look at, or?
Yes.
All right, let me look at it.
Well, I kept meeting with the group, so I could at least
Yep.
keep looking at things. But when I first plotted this, it was like here and not, it didn't intersect with that sign.
So where did you put your UCS then?
I thought I put it at the center line over here.
Okay, so let's try it now. Why should go the other way?
What was it?
It was just.
And then do this pointing.
Yeah.
You did the 9.5 from
Mhm. Oops. Okay, so let's go up now to your section view. Figure out what's going on there. So I think it must be slightly out of alignment.
Which of the phones is the, like, when we did the ECS up here?
What's that? You see the green line should be that.
Okay.
So that looks right, but
I honestly think that's where I got messed up. If can I be my ECS?
mhm.
So I think I might have had it here.
Yeah.
This one I need not the water, but the zero.
Yeah.
Oh, no.
Is it the negative like 30?
I wrote all these things down so I wouldn't forget.
Zeros are really 87. Yeah.
There it is. I think you probably had your UCS in the wrong spot.
Yeah, I think so too.
Yeah.
So,
Okay.
So you can just move it in the section. So it needs to be. Anybody else got any weird crime ones that I need to help you find?
Fixing it.
Okay.
Is there?
You wanna
Okay.
be a guest speaker at barbecue?
Barbecue, no.
The speaker?
No, it's faculty.
Oh.
Not particularly.